Hello and welcome to the Missile Defense Agency STEM program. My name is Shari Feth. I am the Program Executive for Advanced Technology. I'm going to walk you through the Missile Defense Agency, what our mission is, how things work, and then explain a little bit about how we use science, technology, engineering, and math career fields to execute our mission. The Missile Defense Agency is a research and development agency within the Department of Defense. Our mission is to develop and deploy a layered missile defense system that will defend the United States, deployed forces, allies, and friends from hypersonic and other missile attacks in all regions and in all phases of flight, all ranges and all phases of flight. And I'm going to explain a little bit what that means, how our system works, as well as what it means to have different ranges and phases of flight. Our vision is to leverage innovative, highly skilled professional workforce. We have an amazing workforce of engineers and scientists, as well as other capabilities such as logistics, human resources, and financial business management. We also leverage work with international partners, as well as work across the entire United States to really solve this very advanced, complex problem of how do you defend the United States against missile attacks. This is an overview of what it is to be the missile defense system at a very high level. You see the interceptor in the center, that big missile that we call these interceptors because they're designed to intercept the adversary's missiles. In general, we don't use a warhead. We actually use what's called kinetic kill, or we use kinetic energy, the energy of motion, to effect a kill. We don't use an active warhead for the most part. What that means is we have to get very, very close, very exact to where the enemy missile is coming. The enemy's missile comes in, and our missile then comes in and intercepts it, and just that energy from the two missiles and their speeds are enough to destroy the incoming missile. That big missile in the center is our ground-based interceptor. That is designed to go against the longest range threats. So I talked about different ranges. When an adversary launches an intercontinental ballistic missile, what we would send up against it would be a ground-based interceptor and try and intercept that as far away from us as feasibly possible. As you can see, there's various other missiles that are layered. I talked about the layered missile defense system. So we have these other missiles that are not as long ranged, designed to either intercept a missile that might have been missed if there were too many, for example, for our ground-based system, or to get shorter range missiles, ranges that the adversary is in closer, all the way down to what we call point defense, which is our Patriot missile there on the far right, if that's designed to defend a small area. Our system doesn't have just interceptors. It has to have the whole system to make it work, just like the human body has the whole system. So the eyes and ears of the human body are the sensors, and those you can see those across the bottom. Those are platforms in all different areas. We have space sensors, we have ground-based sensors, and we have sensors on the water. We use all of that data and bring that into the command, control, and battle management and communication. You see that across the top. That's effectively the brains and the nervous system, the missile defense system. It takes in all of the data from the sensors in the same way that your brain does, and then it communicates that for what you need to do, whether it's raise your hand, or in our case, launch an interceptor against a ballistic or a hypersonic threat. That arc you see in back in white, that is characteristic of a ballistic missile threat. It's governed all by physics. Once the enemy has burned out all of its stages, it just flies along with gravity. It makes it well determined by physics, and so using a lot of math, we can figure out exactly where we need to be to intercept it. The trajectory, that gold squiggly line you see, that we call that a trajectory. That one is a little bit more difficult. That one is typical of a hypersonic or potentially maybe a cruise missile. They launch the same way roughly as a ballistic missile, but then they do a very steep dive to start gaining more energy and then pull up and glide. And this allows them to extend where they're going and have a lot more maneuverability. Those require a lot more information because they can actually maneuver. I would encourage you to view the video called 10 Steps to Intercepts. That will walk you through what all we do in the Missile Defense Agency to accurately hit and destroy. What I want to talk with you through is what are the science, technology, engineering, and math efforts that we use. And so starting with, this is our same 10 steps that you'll view from the video. And I've overlaid on top of that, what are the areas and the knowledge areas that we use in order to address those various different parts of our mission. So you can see we use everything from physics, calculus, trigonometry, algebra. We have to understand radars and EOIR, that's electro-optic infrared type sensing. We calculate exactly where the adversary's missile will be coming in and when and how we need to launch. What we make potential little updates to make sure our interceptor gets exactly where it needs to go to effectively destroy the incoming missile. And so you can see some of the areas that are important to make that happen. Talking through the career fields within the Missile Defense Agency, we do a lot of things. We build, we solve problems. It's all about solving the problems for the Missile Defense Agency. The career paths that we use to get there include engineering, mathematicians, scientists. We use historians as well as public affairs specialists and human resource specialists. Of course, we have our business and financial management area. There's nothing that you can execute without requiring that. We have extensive logistics support. We use our logisticians to operate and sustain our systems in the field, as well as to deploy the systems to make sure they get out there. And we use a lot of technologists, both in information communications as well as pure technology. I employ a number of technologists in the advanced technology area to make sure that we are building the system for the future. What are the great things coming down the road that we can utilize to make our missile defense system more effective? And there are many more areas that we do. We're always looking for good STEM graduates to fill these roles. Some of our typical degrees that we hire include engineering, physics, math, computer science, and business and finance. We also have a scholarship program called the Smart Scholar Program for college students, as well as a few other programs for bringing in new and younger employees. I put up here the websites that you can go to get more information on the work that we're doing, as well as on our STEM activities. Thank you very much for viewing this video on the Missile Defense Agency STEM program. I hope you have an opportunity to see the 10 steps to intercept to better understand our mission and take the opportunity to look at some of our additional information. Thank you.
The 10 steps to missile intercept. This is the missile trajectory with a launch point to an impact point. Step 1. The Overhead Persistent Infrared OPIR satellite detects a missile launch based on its infrared IR signature from the heat generated during its launch. Step 2. Because the satellite only tracks IR, it sends detection data to the network, cueing a radar located within range of the launch of the missile, telling the radar where to look on its horizon for the missile. Step 3. The radar, using the cueing information provided, is now able to acquire and track the missile, determine a trajectory, and estimate a probable impact area. Based on that information, the missile is now considered a threat. Step 4. After the boost phase, the threat missile type, its warhead, and decoys are identified by specialized radars. The various radars provide tracking data to the battle management system. Step 5. Based on the data received from the specialized radars, a fire control solution is planned by the battle management system. The threat missile is targeted during its mid-course phase, and an interceptor is sent its destination information. Step 6. The interceptor's destination is set to intersect the incoming threat missile's predicted trajectory. The interceptor is then launched containing a kill vehicle and follows the flight path determined by the fire control solution. Step 7. As the threat missile flies to its impact area, tracking information obtained from the radars is used to update the flight of the interceptor. Step 8. The video on the left shows the kill vehicle using onboard sensors to search for, track, and identify a target object. The video on the right shows the kill vehicle using small onboard rockets to guide it to the target object. Step 9. The kill vehicle, using hit-to-kill technology, impacts the target object, and the resulting collision essentially vaporizes it. Step 10. After intercept, radars are used to assess if the target object was in fact destroyed.